Our journey begins in the busy port of Hamburg, home to more than 6,000 ships. And here we meet Betsy. Betsy crosses thousands of kilometers from Hamburg to New York, burning huge amounts of fuel to deliver goods across the ocean. Every year, that means massive fuel consumption, and with it, enormous CO2 emissions. Shipping is essential to global trade, but it comes at a high environmental cost. Just one vessel following a regular route can generate a significant impact of around 170,000 tons of CO2 a year. While engineers have focused on making engines more efficient, we asked, what if the real breakthrough isn't about the engine, but about the water itself? Beneath the waterline, a hidden issue grows: biofouling. Biofouling starts with a slimy film of bacteria. Then algae, barnacles and marine invertebrates layer on, adding weight and roughness. This means more friction, more fuel and more emissions. 0.5 millimeter of slime can raise fuel use to 25%, in severe cases by 50%. And it's not just about fuel. Ships carry these organisms across oceans, where they invade fragile ecosystems and outcompete native species. Biofouling slows ships down, drives up costs, and spreads ecological damage. And it affects nearly every vessel at sea. We found that while whales, manatees and ships accumulate marine growth, sharks stay clean. Sharks have been gliding through oceans for hundreds of millions of years, fast, efficient and nearly free of fouling. The secret lies in their skin. It is covered in thousands of tiny tooth-like scales. These riblet structures angle backward, making the skin smooth in one direction, rough in the other. This texture shapes how water flows, reducing friction and turbulence, and it leaves almost no chance for algae or barnacles to stick. Scientists have developed a riblet pattern that imitates the effect of shark skin. We intend on testing different combinations of patterns to optimize the design for underwater usage using a standardized procedure. At the end, we choose the final design. We will then look for partners to refine the application process. Using advanced techniques, a master template is imprinted onto a coating layer. As it cures, the mold dissolves, leaving behind a textured surface that reduces drag and prevents fouling. This structure helps reduce turbulences and limits the ability of marine organisms to attach, cutting both fuel use and emissions, without relying on toxic chemicals. With this project, we intend on working on optimizing the riblet structure with a standardized testing procedure and validate this approach across different vessel types. Riblet coatings offer a promising, non-toxic alternative to traditional anti-fouling methods, combining efficiency with environmental responsibility. By learning from nature, we can move ships more cleanly and efficiently, saving fuel, cutting emissions, and protecting marine life. We believe that a small change can make a sustainable difference. Cleaner shipping, cleaner oceans, a sustainable future within reach.